Hey guys, so today is our first of two lessons about linear inequalities. So today we're going to be going over how to graph inequalities as well as how to write them based on like word problems and stuff like that. And then tomorrow we'll actually go over how to solve those linear inequalities. And by inequalities, really all that we're talking about is any kind of equation that includes a greater than or less than sign. And when we talk about graphing them, we're not actually graphing them on like a graph, the way we would graph like a linear equation. We just graph them on a number line. So it's a lot easier than normal graphing. So let's get into it. So this is lesson 5.7, graphing linear inequalities. And like I said, an inequality is anything that includes a greater than or a less than sign, also a greater than or equal to or less than or equal to sign. And we do graph them on a number line. If the variable is greater than the number, the arrow is going to point to the right. If the variable is less than the number, the arrow will point to the left. You're going to use closed circles, which just use like look like this. If our greater than or equal to or less than or equal to sign is being used, we're going to use open circles, which look like this, if we're just using the normal greater than or less than signs. We're also going to use arrows for rational numbers and dots only for integers, whole numbers, or natural numbers. And I realize that a lot of that probably doesn't make a ton of sense, but hopefully with some examples, it will start to come together a bit more. So for the first example, we are just going to graph x is greater than or equal to -1. So we'll start just by drawing our number line. And it doesn't really matter how many numbers you have on your number line as long as we can represent this. We're going to start just by drawing a circle where the number is. So in this case, the -1. So that'll be right here. And then because it is a greater than or equal to sign, we make sure that our circle is closed. Then because our variable is greater than -1, the x is greater than or equal to -1, that means that our arrow points to the right because our x values, all of the different possible x values are all bigger than -1. So we have to represent all of these numbers that are bigger than -1. And then we use an arrow to kind of show that this would continue on if our number line was longer. Okay. If it doesn't say what type of number, we assume that all rational numbers are included. That is why I've used this arrow here. Let's do a second example. So I'm going to say that -2 is less than or equal to x, which is less than 4. So this time I have two numbers. We're still going to, of course, start with our number line. Because I've got the number 4 here, I have to, of course, make sure that my number line includes that number. And so I'll start by drawing circles where my -2 and my 4 are. Because the -2 has a less than or equal to sign, it must be a closed circle. Because the 4 is not or equal to, it's just the 4 is greater than the x, we leave it as an open circle. And then this time, again, because I haven't told you what type of number this is, we assume that it is a rational number. All we do is connect those two dots, like so. Okay, let's do one where I tell you what type of number it is and it's not a rational number. So for instance, if I said that x is greater than or equal to 3 and x is a whole number. Again, we're going to start with our number line. I'm going to start by drawing my circle where the number is, so where the 3 is. Because it is or equal to, I close my circle. I then know that because x is greater than 3, I'm once again going to be moving to the right. So I'm going to draw a little arrowhead to the right there. But because it's whole numbers, I use dots only, not a line. So I'm just going to use dots in the direction of the arrow instead of a line in the direction of the arrow. And the dots just go right over the whole numbers, or the arrowhead goes right over the whole numbers. Okay. Yeah, I think that's it for graphing inequalities. The next thing I want to look at is how to write them. So when we're writing inequalities, you'll be given a scenario, and then you'll have to identify whether your variable is greater than, less than, greater than or equal to, or less than or equal to the number or numbers that you're given. Usually, if you only have one number, you would write the variable, then the symbol, then the number. So that's the case here. We're only given one number. So I'll start with the variable. So it says the temperature must be kept below -4 degrees Celsius. So I'm going to use T for temperature. And then obviously my number is -4. And then I just have to figure out what symbol goes in between them. So because the temperature has to be below -4, that means the temperature must be less than -4. And it says it has to be below -4, which means it cannot be exactly -4. So that's why we don't put the little or equal to sign here. The temperature is less than -4. It cannot be exactly -4. Okay, in this second example here, I will eat 2 pieces of pizza, sorry, at least 2 pieces of pizza, but no more than 6. You have been given 2 numbers. Now, when you're given 2 numbers, the order is always number, symbol, variable, symbol, number. So I'll always go my smallest number to my largest number. So 2, some sort of symbol, variable, so maybe the number of pizza slices I'll eat, symbol, other number. Okay, so numbers are written from highest to lowest. The symbol has to be in the middle. And then I just have to, or sorry, the variable has to be in the middle. And then I just have to figure out what symbols I need to separate my number from the variable. So because the number of pizza slices that I eat has to be more than 2, I'll say P is greater than 2. And I always read from the variable. So that's why I'm saying P is greater than 2. And because it says I'll eat at least 2 pieces, that could be that I just eat exactly 2 pieces. So P is greater than or equal to 2. Now, when it comes to the 6, the number of pizza slices I eat will be no more than 6. So that means my pizza slices will be less than 6 or could be exactly 6, but it won't be more than 6. Okay, so this is what my equation would look like. Just to kind of go over those rules again, we write our numbers. Numbers are written smallest to largest. So smaller to largest. And the variable must be in the middle. And the variable is separated from the numbers by whatever symbol you're using. So whether it's the greater than or less than or greater than or equal to or less than or equal to signs. Another handy rule to notice is that these two symbols, they don't have to be the exact same, but they do have to be facing the same direction. So this could be a greater than or equal to, and this could be just a greater than sign or whatever. But they do have to be facing the same direction as each other. Okay, so as long as you remember those rules, really it's just paying close attention to the wording of the problem to figure out which symbols you should be using. So in this case here, if instead of saying no more than 6, if instead of that one part there, if I changed but no more than 6 and instead said all the rest of that the exact same, but said I will have fewer than 6 slices instead, most of my equation would be the same. I'm still having at least 2 slices of pizza, but my number of pizza slices will be less than 6, and if it's fewer than 6, it is not equal to it. So again, in this case, my signs aren't the exact same as each other, but they are still pointing the same direction. Okay, that is it for today's lesson.